Okay, so we presented before, the basic fundamental feature of renewable resources. We mentioned the fact that if we overexploit them, basically the outcome, the yield is going to decrease. And we understand that there is basically a range of values, if you want, of fishing efforts that allow to maximize the yield. And now we wonder why we should exceed that effort. And in order to show you that, I'm going to use a classic example in fishery management, which is the fishery dilemma that has been basically developed by Clark on a seminal paper on bioscience in 1981. This example assumes there is a fish stock, a single stock, with two competing fleets, and we call that, for simplicity, the fleet A and the fleet B. And there are two harvesting strategies, that is to exploit with moderation the resource, or exploit at a high intensity our resource. We represent the outcome here in terms of, say, net revenues, millions of dollars for each fleet under different assumptions when we get the fleet A and the fleet B, and each of the fleet can either decide to exploit in moderation, in coordination with the other one, an MSY basically, or fish at a high intensity. Okay, and the idea, by using the example that we showed before, is that if both fleets exploit the resources in moderation, each of them is going to gain $3 million per year. Okay, altogether is $6 million, which in fact altogether correspond to the maximum sustainable, profit in this case of the previous example that we just saw before. Okay, if on the other hand, fleet A decided to exploit the resource in moderation, but fleet B decided to exploit with high intensity harvest as much as they can, the outcome is reported here. The fleet B is going to gain $4 million, the A is going to get only $1 million. In the overall, it's $5 million. Do you remember we had the $5 million before as well? Likewise, symmetrically, if fleet B exploits with moderation, A with effort, A is going to gain $4 million, B is going to get only $1 million. And if they both exploit at high intensity as much as they can, if they push on the accelerator and try to get more, each of them is going to exploit $2 million. Okay. Now, the point here in in sort of this game theoretical approach to understand, what are the strategy, how the two fleets can decide what is the best outcome for them. Now, if there is a good cooperation between fleet A and fleet B, we can assume that each of them might decide to coordinate and plot and basically exploit with moderation, and each of them give $3 million. But if there is no communication among the two fleets, or there is no trust, or there is not enforcement, no control of what each fleet is doing, then let's look at what is the sort of a line of reasonings for each of these fleets. And let's pick up, for instance, the fleet A, and fleet A, we can think that CEO of fleet A, or the director, basically make this reasoning. They make assumptions and say, well, we really don't have good communication with fleet B, so we're not sure what they do. But if they fish with moderation and we fish with moderation, we're going to get, I'm going to get, I don't care what the other do, but I'm going to get $3 million, which is okay. But the point is that if I decided that rather than fishing with moderation, I would fish at a high intensity, if that is the case, I would gain $4 million instead of 3. And who cares about the fleet B? Okay. On the other hand, I'm not sure what fleet B does, but probably they will push on the accelerator themselves. And if they do that, then I'm gonna get, and if I fish with moderation, I'm gonna get $1 million. Okay, regardless what B does. And if I decided to fish with high intensity as well, as much as fleet B, then I'm gonna get $2 million. Okay, so the fleet B basically might make, in the absence of cooperation, the same strategic, thinkering of the fleet again. And if this is the case, basically, the outcome for fleet A, if I am the CEO of fleet A, is this one. And it is, if my competitors, fleet B, fish with moderation, and I decided to fish at high intensity, I will gain $4 million instead of 3. I'm gonna get a net benefit. It's worth for me doing that, absolutely, okay? And on the other hand, if the fleet B has decided to push the accelerator and fish at high intensity, in this case, I should also exploit the species at high intensity, because in this case, I would gain $2 million instead of $1 million. So regardless of what fleet B does, in absence of cooperation, I'm definitely better off to put the accelerator and fish as much as I can, as fast as I can, okay? And the point is that the fleet B symmetrically is mirroring basically the same type of reasonings, and so they will also decide that regardless of what I choose, they're going to be better off if they exploit the resource at high intensity instead of moderation, because they're going to get $4 million instead of 3 if fleet E fish with moderation, and $2 million instead of 1 if their competitors, the fleet A, fish at high intensity, the resource. So basically, the outcome of this is that in absence of cooperation, okay, of regulations, of control, of enforcement, the outcome is inevitably and inherently to overexploit the resource, because any fish left by myself will be fished by somebody else, and I can't afford it, because I'm gonna be worse off if I don't try to catch that fish before the other one. So the interesting aspect of that is that this outcome, which is a natural outcome in an absence of cooperation, is basically inefficient both ecologically and economically. It's ecologically inefficient because I'm going to overexploit the resources. My stock is going to become so small that it's, productivity basically, is just dropping down dramatically. And it's also economically inefficient because whether I see from the individual, competitive point of view, I'm gonna, gain $2 million instead of 3, and collectively, because the collectivity is gonna gain in the overall $4 million instead of 6. So it's basically bad from any angle we see that. It might be good only in the short run, in the transitory, when I get that extra fish and got the perception I'm doing better, but in the long run, it's going to dramatically, lead the population to the verge of collapse, economic collapse and ecological collapse. Fisheries to avoid overexploitation? Well, I want to briefly mention here because I think it's important, but I'm gonna glance over pretty quickly because we're gonna come back, the next class in few days to the same argument. But basically, I just want to summarize there are non-exclusive approaches like restriction of fish age, size, and and which type of basically fish we want to to fish. I'm gonna skim it through that. You get into the PDF of the slide, but there are regulation of catch size like total allowable quotas or per capita landings, per capita fishing days. There are restriction to engine power, of course, that are important to the boat size, are crucial for the reason that we saw at the beginning of this lecture here. There might be seasonal closures and, like closing temporary nursing areas. There is all these issues of rotating NPA. Actually, the temporary closures has been used in the past and is now living a second renaissance in terms of what is called dynamic ocean management, and understanding that we don't have to close fishery all the time, everywhere in specific places. We have to do that, for instance, when we want to avoid to basically take a dent on the spawning stock or avoid bycatch. And at the end of this class, we are going to talk explicitly about dynamic ocean management, who's a prominent scientist, Elliot Hazen, who has been leading basic research in this specific field. Permanent closures are still thought a really viable approach and can be part of fishery management. They have the simplicity that you don't have to change where the fishing ground is closed any time, and so they have some additional benefit, especially for conservation purposes. But there are other processes like exclusive access, like fishing, limiting the fishing license, using territorial user right to fish, and then economic approaches we're going to mention a little bit later in this class, including taxes, subsidies, and individual transferable quotas. So we will come back on this, in a day, but I want to briefly summarize some of the most common fishery strategies that have as a goal, for instance, to maximize fishing output, the maximum sustainable yield, with some caveat that we will be discussing, in the week. Another alternative would be to maximize the economic return of fishing activity, either in the short run or in the long term. So, the short run is a little bit as we've seen with the fisherman dilemma, but in the long term, what is the maximum sustainable profit? We could decide to minimize extinction risk, which is another alternative, or to minimize variability in fisheries performances, which is really annoying when the catch is high one season and low another season, because the fishermen cannot rely on a fairly constant source of income. It might fluctuate a lot, and this might be problematic. So we take a little break now and move into the analyzing the interaction between the objective of maximizing, for instance, sustainable yield by using different approach like constant quotas or total allowable catch, and by using like constant effort or a network of no-take areas. So we take a little break and we move to the next video. Thank you.